Hello, I am Mr. Lambert. I am a physics teacher from the Sonderling Center, and today I'd like to read a passage from a book called Barbarian Days, A Surfing Life by William Finnegan. Here's how rideable waves form. A storm out at sea churns the surface, creating chop, smaller and then larger disorganized wavelets which amalgamate with enough wind into heavy seas. What we are waiting for on distant coasts is the energy that escapes from the storm, radiating outward into calmer waters in the form of wave trains, groups of waves, increasingly organized that travel together. Each wave is a column of orbiting energy, most of it below the surface. All the wave trains produced by a storm constitute what surfers call a swell. The swell can travel thousands of miles. The more powerful the storm, the farther the swell may travel. As it travels, it becomes more organized. The distance between each wave in a train, known as the interval, increases. In a long interval train, the orbiting energy in each wave may extend more than 1,000 feet beneath the ocean's surface. Such a train can pass easily through surface resistance like chop and other smaller, shallower swells that it crosses or overtakes. As waves from a swell approach a shoreline, their lower ends begin to feel the sea bottom. Wave trains become sets, groups of waves that are larger and longer interval than their more locally generated cousins. The approaching waves refract, bend in response to the shape of the sea bottom. The visible part of the wave grows, its orbiting energy pushed higher above the surface. The resistance offered by the sea bottom increases as the water gets shallower, slowing the progress of the lowest part of the wave. The wave above the surface steepens. Finally, it becomes unstable and prepares to topple forward, to break. The rule of thumb is that it will break when the wave height reaches 80% of the water's depth. An 8-foot wave will break in 10 feet of water. But many factors, some of them endlessly subtle, wind, bottom contour, swell angle, currents, determine exactly how and where each wave breaks. As surfers, we're just hoping that it has a catchable moment, a takeoff point, and a rideable face, and that it doesn't break all at once, close out, but instead breaks gradually, successfully, peels, in one direction or another, left or right, allowing us to travel roughly parallel to the shore, riding the face for a while in that spot, in that moment, just before it breaks.